Hey guys, you should have just finished your activity and hopefully you have a little bit of idea of what a point estimate is and what your margin of, or not your margin of error, but your confidence interval are. Today, we're going to only work on margin of error, confidence interval. Tomorrow, we're going to work on level of confidence. But before we do that, we have to review. So we need to remember what population, sample, statistic, parameter, those types of things are, because then that can help you understand what we're talking about. So population is all of the things. Now, if we were talking about the activity you just did, it's all of the students in third hour. Our parameter is the data that goes with that. Again, all of the test scores from third hour. But the sample is some of the things. In the case of what you just did, it's the 5 students that you worked with to find the mean. And so our statistic is the data that goes with our sample. Now, one of the things that we need to remember is that our mean of a population is the mu. Funny looking M, I think it's a funny looking U. Either way, it's all Greek letters. You'll need to know them. But our mean of a sample is X bar. And our standard deviation for our population is sigma. And remember, I can't write it well. Good luck. I'm sorry. It's not English. And our standard deviation for our sample, this should say sample, sorry. Our standard deviation for our sample is just an S. So when we're reading through some things, we're going to have to look and see, is it for our population or is it for our sample? Now, what we're learning today is we're learning point estimate. And really the reason we're learning it is because we can't take all of the data for all of the population. For example, if I were to try to determine Biden's current level of confidence that people have in him, his approval rating. If I'm trying to determine Biden's approval rating, we're probably not going to survey all 330 Americans, 330 million Americans. It's not going to happen. So what you're going to try to do is get a good sample of that and then estimate based on that sample. That's what we're doing today. So our point estimate is using that sample information and finding the mean from that. So here we have, it says that a point estimate is supposed to be a single, not signal, single value to estimate the population's mean by using the sample mean. That's what we're going to try to do. For example, you found the mean of your friend's test scores and then tried to estimate the entire class's test scores. Now, this is made up, but let's say I looked at 30 of my followers on Instagram and found out how many followers they had, wrote that down, took the mean. So these are 30 of my followers on Instagram. How many followers they have. Now we're going to find the mean. You are going to do that. This video is going to be paused. You're going to do that. You're going to find it. At least a couple of you are going to shout it out to make sure that that's the correct answer. So pause the video and find the mean. So the mean, when you do all of that data, my mean is 197.53, or really 197. We can't have a half a follower. It doesn't work. We don't like half of people. So that is my point estimate is 197.53. Now, do we think that this point estimate represents most Instagram users? Do most Instagram users have less than 200 followers? That's a big fat no, right? So no, this doesn't. But what we're looking for is we're looking to find a point estimate, a sample mean that is representative of the population. That's what we're going to be working with actually for the rest of the time, because we can't usually get a full population's data. So today, I am giving you some level of confidence and some numbers. These are the z-scores that go with this. We're going to talk about it tomorrow. So today, we're just using these numbers. You're going to use them in your homework, these numbers, and you're going to make sure, and then tomorrow we'll find out where they come from. So if you need to find new ones, you are completely able to do that. But because I'm breaking it down slowly, we are not finding this yet. We're finding it tomorrow. Now our margin of error. What our margin of error is when I take my point estimate and I'm going to add and subtract a number. You guys did that. So I have to figure out what that number is. We use math for that. My margin of error can be found by taking my z-score that's up here, based on whatever my level of confidence is, multiplied by my standard deviation, and divided by the square root of n. So let's find our margin of error. Let's practice. We have to find the margin of error with 95% confidence. So 95% confidence is really, I'm going to put that my confidence, instead of 95%, remember we're going to put that into a decimal, divide by 100, I get 0.95. I have 30 users, that's my n, the number. And I have a standard deviation of 53. Now, because it's a sample, my S is equal to 53. I can replace this population standard deviation with my sample standard deviation. So I'm going to find my margin of error. My margin of error, if I have a confidence of 0.95, that is going to give me a z-score of 1.96. So my margin of error is 1.96 times my standard deviation, 53, divided by the square root of n. Somebody's going to throw that into their calculator. You're going to push pause for this. And you're going to make sure that a couple of you at least all agree on what that margin of error is. So that margin of error you should have gotten to be 18.97 when I put that into my calculator. These numbers I'm going to have to use for the rest of the day. So when we're looking at it, we're going to find our confidence level and going to find the z-score that goes with it. Just a heads up. Flip the page. We're finding one more margin of error before we move on to a confidence interval. So my margin of error, this just gave me a confidence of C. It gave me my standard deviation and my n. So the only thing that I really have to do is I have to convert my confidence level of 0.9 here to my z-score of 1.645. So my margin of error is my z-score that goes with this confidence level, 1.645, times my standard deviation, divided by the square root of n. Again, you're going to put this into your calculator. You all need to know how to do this. Some of you might not even know where to find the square root button, so I need to make sure that you know what you're doing. Put that into your calculator, push pause, and make sure that some of you agree. So my margin of error, when I put that into my calculator, you should have gotten 0.35. Now, I'm not there. Hopefully you all are able to convert your confidence level to your z-score using the numbers I've given you. You are able to recognize your standard deviation and find the square root button on your calculator. The next thing we're doing is we are going to find our confidence interval. So what this is it's a range of numbers that we are going to estimate the population parameter. What that means is that we are going to say that I think that this mean is inside these numbers. The population mean is inside these numbers. That's what you did in your activity, where you said, I think that the average of our test scores is inside these range of numbers, 70 to 90%, something like that, okay? We're gonna do the same thing. Tomorrow, we're gonna put it into story problems, but today we are just using, numbers. So we're constructing a confidence interval. That means that we are going to find our margin of error. We're going to add and subtract it to our mean. It's going to give us a range of numbers. First thing I have to do is I have to find my margin of error. I have a C of 0.9. That means that I have a Z-score of 1.645. So my margin of error is my Z-score, 1.645. That corresponds to my C. Then I multiply it by my standard deviation, 1.5, and I divide it by the square root of n, which is 50. Now, we did that above, and we got 0.35. We're going to take this margin of error, and we're going to add and subtract it to our mean, so it gives us a range of numbers that we think something would be in, which means that I'm going to take my x value, my x bar, and I'm going to add and I'm going to subtract it. So I'm going to do 12.3 minus 0.35. I'm always going to subtract first because it's my smaller number. And that gives me 11.95. And then I'm going to add 0.35 so that I have 12.3 plus 0.35. When I add that, I get 12.65. So my range of numbers is going to be, I'm going to write it like this, 11.95 is less than my mean, which is less than 12.65. My range of numbers is 11.95 to 12.65. And then we have to interpret this. And so the reason we're doing it now is because then as we build onto story problems, it'll help us understand what's going on. So what this means is that we are 90% confident because of my confidence level. Hopefully you can see that the 0.9 means 90%. We are 90% confident that the interval, this interval, 11.95 to 12.65, captures the true mean. So we are 90% confident because of our confidence level that the true mean is somewhere between those numbers because of our margin of error. We're going to practice one more time, and then you guys have homework. In the homework, it might be a story problem, but it's still going to be finding either just the margin of error, or it is building a confidence interval where you're finding the margin of error and then you're adding and subtracting it from the mean. So we're constructing our confidence interval. We are using the same z-score. We have a confidence of 0.9, which means I have a z-score. I'm going to even write that down for you. A z-score of 1.645. You'll find that on the other side of your notes. Tomorrow we'll find it ourselves. And I have my standard deviation is 1.5, but now the sample size has changed. So my margin of error, my pen is dying, hold on. My margin of error is going to be equal to my z-score, 1.645, times my standard deviation, divided by the square root of my sample size. When I put that into my calculator, I'm going to get 0.55. So now I need to build my interval, which means I'm going to add and subtract my margin of error. I'm always going to subtract first because it's it gives me a smaller number. So I have to subtract it from my mean, which means 22.9 minus 0.55 gives me 22.35. Yep. And then I also have to add it. 22.9 plus 0.55 gives me 23.45. Okay, so this is my confidence interval. We're going to write it. What this means is that mean, that average, is somewhere between those two numbers. Now we are going to interpret it. We're always going to interpret it because I feel like you guys don't ever understand anything I say. Maybe you will now. We'll see. Okay, so what does this mean? What this means is we are 90% confident that the interval values (22.35 to 23.45) capture the true mean. What we're saying is that we are 90% confident that that true mean, the true average, is somewhere between those two numbers. We're not 100% confident. In stats, we are never 100% confident. We can be 99% confident, but we can never be 100% confident because stats is a total guess. We make things up all the time. So hopefully this helps you understand. Hopefully this interpretation helps you understand what the confidence level means and what your confidence interval is. Tomorrow, we will be doing another activity, some more notes, some more homework. The homework, it's circled for you. So you are doing, I don't know, maybe 10 problems. I don't even think that many for you to do. You're doing margin of error and you are doing confidence intervals. I need you to do those so that we can move on and so that you do amazing on the test. We don't want anybody to be failing. We want everyone to pass with A's. It would make me the happiest girl in the world. So you guys have a fantastic day and I can't wait to see you Monday.